Hey there guys, welcome to your unit review for the Unit 7 review, Quadratic Equations and Inequalities. So hopefully if you're struggling with anything on review, this video is helpful. Now for problems 1 through 4, they're asking you to solve quadratic equations. So what that means is that we have to get answers that look like x equals 4 and x equals 5. Now there's different methods to solving, so that's what numbers 1 through 4 is going to be testing out. So you'll see that number 1 specifies you have to solve by factoring. Number 2 specifies by completing the square. Number 3 by using the quadratic formula. And 4 using square roots. So to start with the first one, by factoring, we're going to have to first make sure it's equal to 0. So I see I have a positive 11x. I'm going to subtract 11x from both sides. This cancels out, but I also have a plus 6. I'm also going to subtract 6 from both sides. And my new problem will now become 2x squared minus 11x minus 6 equals 0. Now the order that you write it does matter. The variable squared, usually x squared needs to go first, then the number with an x, and then your constant, the number without the x. So order does matter. Now this is the one where we're going to find two numbers that multiply to be something, but add or subtract to be something else. In this case it has to subtract since our last term is negative, but we'll see here. Now we're going to multiply the first and last term, so 2 times 6 is how we're going to get negative 12. So 2 times negative 6 is negative 12. Your middle term is always what you're adding subtracting to, but in this case, since our last term was negative, we have to subtract to be negative 12. So we need two numbers that multiply to be negative 12, but subtract to be negative 11. Well, in that case, we're going to use 1 and 12. 1 times 12 is 12, so we need to be negative 12. If I do 1 times negative 12, I'm going to get negative 12. And if I do 1 minus 12, then I'm going to get negative 11. So the way to use this number is what we're going to do is we're going to bring down the 2x squared. But then, let me pick a different color. We're going to take the two numbers we found. So I'm going to write plus 1x. Whatever numbers you find, make sure to add x's to it. And the minus 12x. And then we're going to bring down the minus 6 equals 0. So all we did is that we took our middle term, the negative 11x, and we separated into these two terms. Because 1x minus 12x is negative 11x. We haven't changed our problem. Our next step is we are going to draw parentheses around the first terms and the last terms. And we're going to find our greatest common factors. So the greatest common factor of 2 and 1 is just 1, but they both have x. So I'm going to say my greatest common factor of 2x squared and 1x is just x. From here, I'm going to work backwards. I'm going to say x times 2x is 2x squared, and x times 1 is going to give me that 1x. Now for my second parentheses, be careful. Most of you want to immediately draw your next parentheses because you know what your answer should look like, but we don't do that yet. We're actually going to bring down the sign that's in the second parentheses. So in this case, it's a minus, so I'm going to bring down a minus. And then I'll find my GCF like I did for the first parentheses. The greatest common factor of 12 and 6 is 6. And then I'm going to say, okay, well, they both don't have x, so it's just a 6, and work backwards. Negative 6 times 2x is negative 12x. Negative 6 times 1 is negative 6. Now remember, factor bar grouping is nice because it has a built-in self-checker. 2x plus 1, 2x plus 1, perfect. We know we've done it correctly. So I'm going to take those parentheses that are the same and write it one time, so with 2x plus 1. And in my second parentheses, I'm going to write my GCF, the numbers in front of here. So an x minus 6. Now we're not done. We want to, remember, solve. So to solve, what we have to do is we have to take these and set them equal to each other, or set them equal to 0. We're going to use the zero factor property, or the 0 property. So what we're going to do is we're going to say, okay, well, 2x plus 1 equals 0. Hopefully I have enough space. And we're going to get x by itself. So we're going to subtract 1 from both sides. We get 2x equals negative 1. Divide by 2 on both sides. And you're going to get x equals negative 1/2. Make sure you see that's negative. So that's partly my answer. I can do the same thing here. So let's draw here x minus 6 equals 0, plus 6 plus 6, x equals 6. Now all I did was I took this parentheses, set it equal to 0, solved for x. Took this parentheses, set it equal to 0, solved for x. Now remember, these two not only are my solutions, but solutions is another word for x-intercepts. So these are my x-intercepts for this equation. Now we're done with question 1. Now following along to question 2, it wants us to solve it using completing the square. So we're no longer going to be using factor by grouping. We're going to be using completing the square. Completing the square is the one that you've learned that has all the blanks. So what we're going to do is we're going to rewrite this problem. Plus 6x plus 2 equals 0. I'm going to underline the first two terms and divide by what's ever in front of the x squared. In this case, it's an implied 1. So, usually we don't write implied 1s, but because sometimes when I don't write the 1 in front of the parentheses, it throws off your steps. Whatever you end up dividing by should go in front of the parentheses. Now, in this case, like I said, it's an implied 1, so we usually don't write it. But I'm going to write it just for the sake of those of you who need kind of steps that you can follow along with for a variety of different problems. So we're going to divide it out. X squared divided by 1 is just x squared. 6x divided by 1 is just 6x. After you divide the first two terms, this is where your first blank goes, and you end your parentheses. Then you're going to take this number that we haven't used, that we didn't underline, and bring it down. And after that number will go our second parentheses. And I can write my equal 0 here. Underneath this, I'm going to bring down, don't forget to bring down the number in front of the parentheses, just an x, blank, and your parentheses squared. So once you have your 3 blanks, you can begin completing your square. So to begin completing the square, you're going to take your middle value and you're going to divide by 2. So you're going to say, okay, well, 6x divided by 2. Or my bad, just the 6, not the x. So ignore the x. 6 divided by 2 is 3. Once you find this blank, you are going to square it. You're going to say, okay, well, 3 squared is 9. Make sure even if it's a positive 9, you are writing plus. Some of you will only write a 9. You have to write plus because this is an expression. X squared plus 6x plus 9, not 6x 9. Then you're going to take this blank that you just solved and multiply it by this red number out here, whatever it ends up being, 2, 3, negative 5, whatever. We're going to multiply these two numbers. So 1 times 9 is 9, and we're going to do the opposite. In this case, minus 9. 2 minus 9 is negative 7. Then I'm going to set it equal to 0. From here, we're just going to solve. For x, I'm going to add 7 to both sides. So this is completing the square. Now I'm just solving by square root. So I'm going to add 7 to both sides. So I get x plus 3 squared equals 7. I'm going to put down my 1. Now, like I said, usually we don't do this step. But because some of you like to follow along step by step, I don't want to skip any steps because then that throws you off when the number isn't 1. So before you square root both sides, you have to get rid of what's ever in front of that parentheses. Like I said, whether it's a 2, a 3, a negative 5, doesn't matter. You have to divide it out. So you divide it out before we square root both sides. So that's just going to give us, hopefully I have it on the face, x plus 3 squared equals 7. Because 7 divided by 1 is 7. Once you've divided, I can square root both sides. Squares and square roots cancel out. So that leaves me with x plus 3 equals 7. I actually don't need those parentheses anymore. So let me rewrite it as just x plus 3. And let me also erase this. Since I square rooted that 7, I'm going to write, anytime you square root both sides, you need to write plus or minus. And then I'll bring down my square root 7. Now, usually you would simplify your radical. That is to simplify your square root. But 7 is a prime number, so it actually doesn't simplify any further. So I'm just going to leave it as plus or minus 7. My last step is only to subtract 3 from both sides so that x can be by itself. So I'm going to have x equals, you always write whatever you subtracted or added to both sides first, minus 3 plus or minus the square root 7. And that is your answer. Now, sometimes you separate your answer like you saw on the mid-unit project or your mid-unit test. But in this case, since they're not both constants or integers, we can't add them. If it was negative 3 plus or minus 1, then yes, I can say negative 3 plus 1, negative 3 minus 1. But you actually don't have a reason to want to write negative 3 plus square root 7 and negative 3 minus square root 7. You can, but this is as far as we're going to go for this problem. So we solved the second one. So, not bad. We're going to go to questions 3 and 4 now. Oops. So, let's go down a bit. So, for question 3, it says we need to solve using the quadratic formula. So, hopefully you remember your quadratic formula. Now, luckily, this is already set equal to 0. If it is set equal to 0, then I can start to say this is my A, this is my B, this is my C. So my A is 1, because it's an implied 1 in front of x squared. B is 2, C is 6. So my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c come from here. So I'm going to put parentheses negative b plus or minus, let me write it down here. I'm not going to have enough space. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And I'm going to fill in my values. So negative b, my b was 2, plus or minus b squared, b was 2, minus 4a, which is an implied 1, c, which is 6, times 2a, which is 1. So we're going to end up with negative 2 plus or minus the square root. Now 2 squared is 4, so this is really 4 minus, and you're going to have 4 times 6, which is 24. So this is 4 minus 24, which you just put in your calculator. You can put all of this in your calculator without the square root. So 2 squared minus 4 times 1 times 6, but 4 times 6 is 24, 2 squared is 4, so 4 minus 24, which is negative 20, all over 2 times 1 is 2. Now we can simplify our problem. In fact, we have to simplify it quite a bit more. For example, the square root of negative 20 is the square root of negative 4 times the square root of 5, because negative 4 times 5 is negative 20. But we know that the square root of negative 4 is just 2i. Anytime there's a negative inside your square root, it's impossible to solve, which leads to imaginary answers. So we know that the square root of 4 is 2, and the square root of negative 4 is 2i, not negative 2. Now 5 is a prime number, so it won't simplify further, so it'll stay here. So this is actually going to give us negative 2 plus or minus 2i square root 5 all over 2. Once again, we're not done, because we can divide both of these by 2. So negative 2 divided by 2 is negative 1, plus or minus 2 divided by 2 is 1, so we'll just use the I square root 5. Do not divide the square root by the number in your denominator, only dividing the coefficient of the square root. And once again, since these are not two integers, we're going to leave our answer like this. Let me circle this a little better. Negative 1 plus or minus I square root 5. So now we're going to go to question 4. So for question 4, it asks us to solve using square roots. Now, solve by square root is actually the only time you don't want to be equal to 0. So since we don't want to be equal to 0, we can start solving. Now, for solve by square root, you just want to get your x by itself, so at the end you can square root both sides. So I can see that, hey, to get x by itself, I need to divide by negative 2 on both sides. And that'll give me x squared equals negative 3. Because we know squares and square roots cancel out, so I'm going to square root both sides. X equals, anytime I square root both sides, I need to write plus or minus. Plus or minus the square root of negative 3. But we just talked about it here. Anytime you have a negative inside your square root, it becomes an I. So x equals plus or minus I. Now 3 is a prime number, so it doesn't simplify further. So the 3 will stay inside the square root, but you do want to take that negative inside the square root outside and turn it into an I. So for this one, our answer is just x equals plus or minus I square root 3. And those are your 4 factoring problems. Not bad so far. So we're going to go downwards and solve the next few problems. So let's scroll down right here. So now we're solving quadratic inequalities. Now, quadratic inequalities are mostly the same as solving quadratic equations. The only difference is that we have number lines and we have multiple representations for our quadratic inequality. This is what we're talking about, less than and greater. So, just for that reason, I'm going to write this out. So we have this, or this, which is less, hopefully I can get into it, than, and then you can have this or this, which is greater. So we have and or problems depending on this. So let's start with the first one. Now, these don't specify how they want you to solve, so you actually have a variety of different ways to solve these. So what I'm going to do is I'm going to try to factor all of them. Factoring is the easiest. You can technically always solve or use quadratic formula for any types of quadratic equations or quadratic inequalities. So if you struggle with using any of these methods, you can always just use a quadratic formula. Because I think most people understand the quadratic formula. It may lead you to cases here where you have to simplify a lot. But if you understand how to plug things in and you're not scared of simplifying radicals and you're not scared of fractions, and quadratic formulas may be the case. If you're stuck on a problem on your test and you just can't figure it out, try the quadratic formula. You can even use it for this one. Notice how you have an x squared number. You would have to make everything 0, by the way. But notice how you have an x squared number. You have a number by itself, so you subtract 6 from both sides. You don't have a number with just an x, which means your b is actually 0. So when you use a quadratic formula, you would use b as 0. But let's go back down here. And let's see if I can factor number 5. And by factor, I mean factor by function. Sometimes they're unfactorable, and you have to use quadratic formula. So, for here, first off, talking about making it equal 0, I have to make sure it's equal to 0. So I'm going to subtract 5 from both sides. And that's going to give me x squared plus 4x minus 5 less than or equal to 0. So at this point, I can say, okay, well, let's see. If there is no coefficient from your x squared, you can go straight to factoring. Beautiful. So I need to multiply the negative 5 and add to be 4. Can I get that to happen? Now, since my last term is negative, that means I need a positive and a negative number because positive times negative is negative. If I have 2 negative numbers, I'll give me positive. If I have 2 positive numbers, I'll give me positive. So the only way to get a negative 5 is by multiplying a positive and negative. Now, since I want a positive 4, I actually want this 5 to be positive and this 1 to be negative. Negative 1 times positive 5 is negative 1. Or my bad, negative 5. Negative 1 plus 5 is actually positive 4. Nice. So, if there is no coefficient in front of x squared besides the implied 1, you can actually go straight to your answer. So I'm going to bring down my x's, because the only way to get x squared is x times x, so I know those x's belong here. And then I'm going to put in the numbers we found. So the negative 1 and the positive 5. And then less than or equal to 0. And then to figure out my x values, we're going to do the same thing we did before. You can probably do it in your head, inside opposite. But I'm just going to take my parentheses and set them equal to 0 to find my critical values or my x-intercepts. They mean the same thing. Add 1 to both sides, x equals 1. Subtract 5 from both sides, x equals negative 5. Now that you have your critical values, now you must determine whether you have a less than problem or a greater problem. So to do so, we're going to look at our inequality symbol. So here I see that I have an inequality symbol of less than or equal to. So less than, I have an and problem. So, and problems, I like to draw my number line first. Oh, I might have drawn it a little bit too low. Now for my number line, -5 should always go to the left of 1. -5 is less than. I'm going to put a dot here. I'm going to put a dot here. Since it's equal to, I can actually fill in those dots. And problems, connect. And this is in your packet, so if you need help, look in your 7.5 lesson and your 7.6, no, 7.4 and 7.5 lesson. So this is my number line, but I also want to show it with the other solutions. So for example, -5 less than or equal to x, less than or equal to 1, that's inequality notation, and -5, comma 1. So my answer are these three representations. I know it only asked for number line in the directions, but make sure you know how to write it all three ways for your test. Now for the second problem, notice x squared plus 4x minus 5, x squared plus 4x minus 5. You get the same equation. So we actually don't have to resolve it. We know that we're going to end up with the same answers. So x equals 1, x equals -5 are still my critical values, but there is a small difference between these problems. I say small, it's actually a giant difference. Your inequality symbol, it's greater than, you're greater. So it's actually going to change how we represent our answers. So when I draw the number line, I'm still going to draw the -5 first because it is less than 1, so it should go to the left. And I'm still going to draw my two circles, but there's a few differences. First off, since there's no equal to line underneath, I do not fill in these circles, and since it's an OR problem, they actually don't connect. OR problems go away from each other. And the reason they go away from each other is because when we write the inequality symbol, we're going to write x less than -5. So x can be less than -5, which is true. We can see that we're going to the left. Or x is greater than 1, which we can see here. It's going this way. And then for interval notation, we're also not going to write it like this. For OR problems, interval notation involves infinity. So negative infinity, because we're going all the way left, infinitely, infinitely. -5, curved brackets, this is not equal to. Square brackets are when you have equal to. Union, union tells us that it's OR. Kind of tells us there's a gap in between. 1 to infinity, because this 1 will go here. Now infinities always have curved brackets, so you should never have square brackets around your infinities. So these are the three representations for number 6. So not too bad. Make sure you're studying 7.4 and 7.5, so you make sure you know how to do this. Or you're writing it on your note card. Cool beans. Let's go down. Number 7 and 8. So for number 7, we're going to start similarly. We're going to say, okay, well, I want to subtract 6x from both sides. Now, number 7 is very interesting because it's important, and I see it to be where a lot of students make mistakes. So I'm going to put x squared. Now, the order you write it does matter. This 6x should go before the 5. Because you always write in the form of your x squared, then your just x, and then your constant, the number without the x. So then we're going to keep the greater than or equal to 0. And we're going to factor. We're going to see if it's factorable if I have to use quadratic formula. So it needs to multiply to 5. It needs to multiply to be a positive 5. But add to be a -6. Well, the only way to get a 5 is 1 and 5. But can I get it to be a -6? You can indeed, by making them negative. -1 times -5 is +5, and -1 minus 5 is -6. And once again, since there's no number in front of my x squared, I can go straight to my answer. That is to say, I can write my x's at the start of these parentheses, because x times x is the only way to get x squared. And then we're going to use 5 and -1. Because -1 times -5 will give you that 5, -1x, -5x, you do -6x. Greater than or equal to 0. And if you solve it, we kind of solved it above already, but I'll resolve it. X minus 1 equals 0, add 1 to both sides. x equals 1, x minus 5 equals 0, add 5 to both sides, x equals 5, and then I can see, ooh, that's really cool. These are my critical values. So for these critical values, I can see that, hey, once you have a critical value, similar to what I said before, you want to determine whether you have less than or grade 4. Now I can see that I have greater than or equal to, so that means I have a grade 4 problem. So to write my OR problems, they have a very specific notation you're going to use. Like I said, go do 7.4 and 7.5 lessons to look for those notations. They're in your packet. So I'm going to draw my number line. 1 smaller than 5, so it's actually going to go before this. I'm going to draw my 2 circles. And then I'm going to check, okay, it is equal to, so I can fill in these circles. And it's grade 4, so OR problems face away from each other. And then for my notations, OR problems are x is less than or equal to 1, or x greater than or equal to 5, because we're getting less than 1 or greater than 5. Like I said, if you don't have these notations memorized, please put them on your packet for your Unit 7 test. And then interval notations are the ones with the infinities for OR. So negative infinity, comma 1. We're going from the negative infinities up to 1. This time I am going to use a square bracket because it is equal to. Union, because there's a gap. Square, oh, that's a little bit too close. Square bracket, because it is equal to my 5, which goes to positive infinity, which infinities always have the curved bracket, or just the parentheses. Oopsie. So these are my 3 notations. Pretty neat. Oh, that's kind of a square rectangle box. Oh, well, good enough. Number 8. Luckily, we see that similarly what happened with numbers 5 and 6 happened with 7 and 8. I have x squared minus 6x plus 5. I have x squared minus 6x plus 5. I'm going to have the same critical values, which was x equals 1 and x equals 5. The only difference is that this time it's a less than problem. I have an and problem. So it's going to change my notation. So 1 and 5, and problems will connect. Now I'm not going to fill in my circles because it is not equal to. And then for my notations, it's going to be 1 less than or equal, oh, not equal to, less than x less than 5. This is and notation, and then since it's not equal to in these parentheses, 1 comma 5, or that means to say it goes from 1 to 5, the comma is not a coordinate point, it's kind of a saying I'm going from 1 to 5. And these are my 3 notations. Ta-da! Pretty cool!